The Earth is constantly changing, most especially its plates. The Earth looked different in the past. There was only one continent called Pangaea. Now, there are seven continents. This is because of plate tectonics, which states that Earth's outer shell is divided into several plates that glide over the mantle. The plates act like a hard and rigid shell compared to Earth's mantle. Due to the convection currents in the mantle, underneath the crust, the plates constantly shift, move, and interact with one another. An effect of this is earthquakes. The USGS, or the United States Geological Survey, estimates that several million earthquakes occur in the world each year. Many go undetected because they hit remote areas or have very small magnitudes. Earthquakes can be classified as a geological hazard, as well as its other related hazards, like tsunamis and liquefaction.
Earthquakes are usually caused when rock underground suddenly breaks along a fault. This sudden release of energy causes the seismic waves that make the ground shake. When two blocks of rocks or two plates are rubbing against each other, they stick a little. They don't just slide smoothly, the rocks catch on each other. The rocks are still pushing against each other but not moving. After a while, the rocks break because of all the pressure that builds up. When the rocks break, the earthquake occurs. During the earthquake and afterwards, the plates or blocks of rock start moving, and they continue to move until they get stuck again. The spot on the ground where the rock breaks is called the focus of the earthquake. The place right above the focus is called the epicenter of the earthquake. Distant forces cause a gradual buildup of stress in the earth over tens or hundreds or thousands of years, slowly distorting the earth underneath our feet. Eventually, a pre existing weakness in the earth, called a fault or a fault zone, cannot resist the strain any longer and fails catastrophically. This is something like pulling a rubber band gradually until the band snaps. This theory is known as the elastic rebound theory.
Tsunamis, on the other hand, usually occur because of underwater earthquakes at the seafloor. When large slabs of rock are forced to move past each other, suddenly, causing the overlying water to move. The resulting wave moves outwards and away from this event.
Liquefaction happens only on land which is mostly composed of soil which has water within them. When an earthquake occurs, the water pressure in the soil increases and causes the weakening of the soil. It causes soil to move and render it unable to support anything above in like buildings.
Know the height of your street above sea level and the distance of your street from the coast or other high risk waters. Evacuation orders may be based on these numbers. A tsunami advisory is issued when a tsunami with the potential to generate strong currents or waves, dangerous to those in or very near the water, is imminent or expected. The threat may continue for several hours after initial arrival, but significant inundation is not expected for areas under an advisory. Find out if the foundation of your living space is under rock or soil. If it is soil, be ready to evacuate when an earthquake occurs. The study of geology also encompasses earth processes which may affect overall civilization. An earthquake can destroy thousands of lives in a few minutes. Also, tsunamis, floods, landslides, droughts, and volcanic activity can have an enormous influence on civilization. Geologists study those processes and can recommend action plans to minimize damage in case such events will occur. For example, by studying flood patterns of rivers, geologists can recommend areas to avoid when building new cities, towns, and residential neighborhoods in order to prevent future damage. Earthquake science, although a very difficult area of study, can help minimize damage to life and civilization by estimating where earthquakes are most likely to occur, and to recommend the type of technology to be used in the construction of buildings in these vulnerable areas. This understanding is shown in this interview with a soldier who partakes in relief and rescue operations for natural calamities such as earthquakes.
Nakaranas ka na ba ng relief and rescue operations habang may kalamidad tulad ng lindol o bagyo?
Maranas na po yung bagyo.
Nakaranas. Ano po yung pagkakaiba ng training mo para sa combat at ang pagkakaiba sa relief and rescue operations?
Ang pagkakaiba kasi mas delikado sa combat kasi unang-una buhay namin yung nakasalalay. Nag-operate kami sa bundok. May hawak kaming baril. Isa lang naman ang buhay natin. Kaya kung ikukumpara namin, mas delikado yung sa combat operation.
Anong kailangan na skills ng isang soldier bago siya maging parte ng isang rescue operation?
Lahat naman sa amin is bago ka pinapadala sa mga rescue, dadaan ka muna sa mga seminars, halimbawa yung mga paglangoy, gano'n. May mga seminars kayo bago kayo pinapadala sa mga rescue.
Pwede mo share sa amin yung experience mo sa operations nito? Saka anong mga natuklasan mong mahirap doon?
Ang mahirap yung kasi may mga kasama kasi kami na parang hindi sila sanay sa pag-rescue kasi hindi nga nila na master yung mga seminars. Tapos pagka nagre-rescue sila hindi na i-apply yung safety sa kasi siyempre pagka may nangyari sa nagre-rescue mo, kami yung malilintikan.
Kaya, bakit importante ang pagkahawak ng seminar at drills tungkol sa lindol saka bagyo?
Kasi iniiwasan po natin yung disgrasya. Kasi pag may disgrasya, katulad yan sinabi ko kanina, kami yung malilintikan sa mga officers namin. Kaya nagkasagawa ng mga